When designing an API, in this case a console game engine, that someone else might use, it is often a good practice to think how will someone else use it. Let's try and think about it in terms of how will I make a snake game. We will need a coordinate system, so we will use X and Y axes, and every object will have their own position, which consists of X and Y coordinate. And we can also store the type of item that is located on that X and Y coordinate. It will mostly be nothing or floor or something, whatever. For now we will only have 3 types, so it will either be a snake, an apple or floor where we can move. So let's start by creating this coordinate system, and since it is basically a grid, I'm going to create a grid class which will have a way of taking X and Y coordinates, and it will return what is located in that grid cell. Let's start implementing that. Let's start by going from the simplest to the hardest parts. So let's just create point. It is simply a pair of coordinates, so X and Y, and let's just override ToString so that we can view it in the console or in the debugger. Next up, we will have a grid cell, which will hold information about what is in the grid cell, where is the cell located, and what type of cell it is. So first thing, we will require a point, which is the position. Then let's have the type. Let's create a class which will list all of the available types. So let's for now create snake, apple, and ground. And let's by default set the cell type of ground. What we want to do next is create a cell stack. So for example, if I say in the grid I want to get row 15, that would be this row, I will call that a cell stack. If I say I want 15,5, then I will just return the grid cell. So basically a cell stack is a collection of cells, and from there we can access a certain cell at a certain Y coordinate, 5, 6, and so on. So let's create the cell stack, and I will call it grid cell stack, and it will be just a collection of cells. In order to initialize it, we want to pass in the X coordinate where this cell stack is located. And we will set the cells equal to, and let's just use the enumerable class to create, let's just say we want to repeat number 0 as many times as there are stacks. If we look at the drawing over here, this is a stack, we will have another stack here, and so on, and the number of stacks depends on the width of the canvas, window width in characters, but let's call it canvas from now on, it will be simpler. So I'm going to create canvas class, and I will define the width and height in here, which will just reference the window width and height in characters. Alright, so we have the canvas width and height, so let's use those over here. So we want to create as many cells as canvas width, and let's convert those into grid cells. Each item that we create, we can grab its index. Over here, this index is actually a Y coordinate, so let's just call it Y. And let's use new grid cell and provide the position, which is equal to X is X and Y is Y, and we have to convert it to a list. There we go, that's our grid cell stack. So we provide the X, which is over here. We create that many elements as canvas height. Oh, so I should fix that. So there are this many elements, so up to here, and every element in the list has, so it starts from Y equals 0, then Y equals 1, Y equals 2, and so on, and the X value is fixed. That's why we provide it in the constructor. So let's fix this to height, and let's expose the way of fetching the specific cell by providing the Y value. So we will return the cell at the y coordinate. Okay, so we have the cell stacks, and now we have to create the grid, which is just a collection of those stacks. So let's create a collection of stacks. And let's provide them in a similar fashion like we did in GridCell stack. So this is cell stacks. We want to go the whole width of the canvas. This is now the x value, and we want to create the GridCell stack and just provide the x. There we go, and we want to expose the methods for getting a specific GridCell stack. So if you provide the x coordinate, we want to return the cell stack at that x coordinate, and we want to also allow getting the specific grid cell, which is at x and y. So we just use cell stacks at that x coordinate, and we can use the y, and that's it. Let's just change this position to init only, because the position will never change, and let's add the ability to say which entity is over here. And this is nullable, and it will be null by default. So there are no entities over there by default. And let's create a ToString for that. Let's create ToString for cell stack as well. Okay, we have ToString methods on all of these, and let's create one like this for the grid as well. This will be cell stacks, and let's add a grid to the canvas. And let's just check out what is inside it. Okay, so the position is correct, 25,5. Let's check out how this looks. Okay, so it's just showing us all of the elements over here. And now that the coordinate system is working, let's add point generation into the canvas class. So let's add random x generation, y generation, and also point generation. So what we are going to do here is use the random.shared, which allows us to generate random numbers. Next method generates a random int. Next double is for doubles. So we want to generate a random number between 0 and width, but we don't have to specify the 0. It will be the default value, so let's just specify the width. And what this will do is generate a random number between 0 and width, but it will not include the width. Let's just do the same for the y. This will be height, and let's do the same for a point. Let's reuse these methods. Let's also allow in the grid to access a cell by using a point as well. There we go, and now we can randomly generate an apple on a random point of the map. So let's just say canvas.grid at canvas.getRandomPoint dot entity equals, let's say, apple. Let's actually put this into a variable so that we can debug this. So let's get that grid cell, and let's put a breakpoint over here. Okay, I have a semicolon missing. We generated 55,1. That's alright. So the maximum would be 59 for the x and 29 for the y. And as you can see, it is correct. Entity is indeed apple.